So what we've done is we've created a web page where you can practice different ways of performing Gaussian elimination. Notice that it's organized by unit, 6.2.1, 2.2, 2.3, etc. These are the different ways in which we're going to do this. And then several problems have been preset, problems 1 through 5 at the top here, and then if you need more practice you can just do random problems. So what we're going to do is look at problem number 1. And when you click that, you notice that in each of the units you see the same problem displayed. And what we're going to do right now is we're just going to focus on the first one. So the first thing you should do is copy over this linear system. You should then go and by hand perform all of the operations. And then when you're done, you can come back and check what you've done by filling in the multipliers right here. Copy over the equation. Okay. So we have 3 equations and 3 unknowns. And now when we do Gaussian elimination, what you end up doing is taking 3 times, let's see, how should we do this? We'll say take row 2 minus something times row 1 to update this equation. And take row 3 and subtract off something times row 1 to update that equation. Now what should that something be? Well, if we take 3 times the first row and we subtract it off of the second row, then we eliminate this term right here. So what we want to do is put a 3 here. Now how do we get that 3 systematically? Well, notice that it's this coefficient divided by the coefficient up here, which is a 1, that determines what multiple of the first row we need to subtract off of the second row. And this here is known as a multiplier. Okay, so then what you do is you write down the system again. The first row is copied. And then the second row, the first term disappears by design. And the second term, you need to do minus 3 times that. So that's minus 3 plus 1 chi 1. So that makes it, let's see, minus 2 chi 1 plus chi 2. Because you do minus 3 times chi 2. Oops, there should have been a 2 here. Minus 3 times 2 is minus 6, plus 7 is 1, so that's where the 1 comes from. And then minus 3 times minus 1 is 3, minus 7 is minus 4. And then to eliminate this term, you take the coefficient here divided by the coefficient there, that's 1. And you subtract, therefore, this first equation from the last equation. And what you get is this term that disappears. 7 minus 1 is 6 chi 1 plus chi 2 minus chi 2 minus 2 times chi 2 is minus chi 2. So probably should get rid of that plus. And then 7 minus minus 1 is 8. And then what we need to do is take row 3 and subtract off something times row 2 to eliminate this term right here. And what's that something? That something is this coefficient divided by that coefficient to create the multiplier. So we get a minus 3. So really we need to take 3 times that equation and add it to the last equation. Okay, 3 times minus 2 is minus 6, plus 6 is indeed 0, so that disappears. So let's rewrite this again. Don't be lazy, just keep rewriting it. Oops, I made another mistake there. And then the last equation becomes 3 times that minus 1 is 2 chi 2 is equal to 3 times that added to that gives us a minus 4. And then what we need to do is perform back substitution to solve this upper triangular system. And how do we do that? We start with the last equation. So from that we conclude that chi 2 is equal to minus 4 divided by 2, which is minus 2. And then we look at the next equation, and we see that minus 2 times chi 1 plus chi2, but now we know that chi2 is equal to minus 2, and that's equal to minus 4. So then if we bring this to the other side, we get that chi2 is equal to, let's see, minus 4 minus minus 2 is minus 2, divided by minus 2, so that should give us a 1. So now we know that well, that's chi1, see, being sloppy again. So we already saw that chi2 was equal to minus 2. And then finally we know that chi0 plus chi1, but we now know that chi1 is equal to 1, plus 2 times chi2, which we know is equal to minus 2, is equal to minus 1, and therefore chi0 is equal to minus 1, minus 1 is minus 2, minus, now let's actually write this out, minus 1 plus 4, and that ends up being 2. So, our solution vector is the vector chi0, chi1, chi2 equal to 2, 1, minus 2. Oh, you may want to see that. There we go. So, for all of the other problems, I want you to go through the trouble of performing all of these steps, writing them out. Do yourself a favor and organize things on the paper in a reasonable way, and that way you're less likely to make easy mistakes along the way. So the multipliers here were 3 and 1, and then if you click on next, you get the next step, which you can then check against what you did by hand, and then you plug in the next multiplier. Notice that if you make a mistake and you click next, then it shows up in red that you made a mistake, and then you have to go back and correct that, and then you end up with your upper triangular system, and then we trust you to be able to go and do the back substitution by yourself without us having any kind of tool to help you through that. But in the end, you can then reveal the solution so that you can check if you computed the right result. Okay, go and do it.